All right. First explore question, or our explore question of the day. We're talking about section 2.7 here. 2.7. I will let you know what that's about in a minute here, but let's get started here. Take a minute to read that question over. All right, so basically what this question is asking you to do to find the tax off a subtotal in a regular sense, like how it's normally done, and then compare it to what would happen if you were to tax each thing individually, okay, each thing individually, and just to kind of compare the two to see if they would be different. And this is a great lead into what we're doing today. So what I want to do is think about the pre-tax total. All right, our total is going to be what? 13 plus 27 plus 73, okay, which is 113. Now I want to tax that with an 8% tax. Remember that my multiplier, if it's an 8% tax, it's going to be a percent increase. Since it's a percent increase, my multiplier will be greater than 1 because I'm trying to increase the price. So if it's 8%, remember 8% can be written as a decimal. How it's written as a decimal is 0.08. So 0.08, since it's over 1. If I do that, I get about 122.04. All right, so the second part of the question, I'm going to do this in a different color here. Second part of the question asks us to tax each little item individually and then find out the total. All right, so what they're saying is do 113 times 1.08 plus 27 times 1.08 plus 73 times 1.08 and add those up. Well, this 13 times 1.08, if you try that, you should get, actually, why don't you go ahead? Give it a shot, add those up. Let's see what happens. Oh, it's 9 o'clock. So what do we do here? I got 14.04, 29.16, and 78.84 to get the exact same total. So really, what we did here, guys, I don't know if you recognize this, though, is we just talked about the distributive property. Okay? The distributive property. All right. And how did we do that? Well, there was two ways we could have done this. I could have done it without the distributive property. Okay, distribute that 1.0 to everything, see if that would make a difference. Or I could have done this problem using the distributive property to see if that would make a difference. And it didn't. Okay, these are the same. These are inherently going to be the same because of that distributive property, because of what it is. So having said that, this section is about the distributive property. Okay, we're going to talk about it in more of a mathematical sense today. That's going to be more of our focus. There are going to be some applications to this, okay, but we'll get there. All right. Can you give it of when it can be used and when it cannot be used? So that's our goal for today. Think about the distributive property. You guys know what it is. This is the using the letters. This is an example. I want to distribute that 3 to everything here to get that. All right. Same idea. If I have a negative, I can distribute the negative. Okay. This is stuff that we've been doing since Algebra 1. All right. So what I want to do, let's apply the distributive property here just to do a little bit of a review. On these next, we have 6 problems. All right. Why don't you try these 3 on your own, and then we'll do the tougher 3 together. Okay, so try these 3. Remember, all you're doing is you're just distributing. You're just distributing. Go ahead and give these a shot. All right, so here's what I got. Distributing that -3, I got -3x squared plus 12x minus 3. Distributing a -1. I chose to add what was inside the parentheses first. Okay, I think that's easier. So I did -4 minus 11 to get -11. And remember, if I have a negative attached to a parentheses like this, that's really a -1 that I need to distribute and I need to multiply to get positive 11. Okay. I distributed 10x. 10x times x squared gives me 10x to the third. Remember, we add our exponents. We're going to do more practice with exponents on Friday. 10x times negative 5x, negative 50x squared, and then 10x times 6 to get 60x. All right, this one should be too bad. Excuse me. Wow. Just because it's attached at the end of our parentheses doesn't mean we don't do the exact same thing. So all I'm going to do is distribute it, but it looks like we're going backwards to become 16 plus 2x. All right. Don't be afraid of the i's. I's are just like x's in a way. All right. They are imaginary numbers. Don't be afraid of imaginary numbers. Okay. There's not going to be any squares, and that's when we get a little weird. So I'm going to distribute the 4 to get 12 minus 8i, and then I'm also going to distribute the 6 to get 48 minus 6i, and then you want to combine your like terms from there. 12 plus 48 is 60. Negative 8 plus negative 6 is negative 14i. And always make sure to write the I second, okay, and the constants first like that. I don't know if you remember this from last year, A plus BI. All right, we need to make sure we're following that format, okay? Why don't you try distributing both of these? So distribute this 2x, okay? And then distribute the negative 5, all right, and see what happens. Go. Okay, so here's what I got. I distribute that 2x, 2 times 6 gives me 12, x times x to the third. Combine my exponents, that is x to the fourth. Okay, then I got negative 8x squared, and plus 20. Wow, a little tired today. Negative 5x, then minus 45. Okay, so now I want to combine my like terms. There's only one x to the fourth. There's only one term with x squared. 22 minus 5. All right, 22 minus 5 is plus 17x, and then minus 45. So don't forget to combine your like terms at the end as well. All right, don't forget that last step. A common mistake here, some people may accidentally try to distribute that 2x to the negative 5. Remember, you're only distributing this term parentheses that they are attached. All right. Suppose you're planning a birthday, so this is now more of a real life application. The birthday party at a water park that charges $17 per child. $17 per child. Okay. 11 children will be attending. Show the distributed property and how it can calculate the cost mentally. Well, I mean, I don't know about you guys, but I would just do 17 times 11. And I don't really know how that shows the distributed property, but I can show you one way in which that might be. If you did 17 times and broke it down to like this, okay? I personally don't know anyone. I mean, I guess, let me rephrase that. If I were trying to do this problem out in the real world without a calculator, for some reason I didn't have my phone on me, maybe it's dead, okay? I would think of it like this. You could always take a number like this, like 11 or 13 or like, I don't know, 110 or something, and split it up. So let's say you had 110 children, okay? If I had 110 children at this $17 or 110, and I wanted to do this mentally, how would I do that? I would do 17 and I would have 100 plus 10, okay? Because I can do 17 times 100 really easily. That just is 1,700. I can do 17 times 10 really easily. That's 170. I'm just adding zeros. And then all I need to do from there is just combine those two numbers, okay? I just need to add those two numbers. So that's kind of what they're saying is, it says can help you calculate the cost mentally. That's what the thing is. But in reality, guys, I mean, you're going to have, if you have your phone with you, I would use my phone. I don't know a lot of people that wouldn't use their phone. Okay? I'm a math teacher, and I'd probably do it mentally because I'm pretty good at math, but all of my friends would probably use their phone. Okay. Having said that, maybe I don't have access to my phone. I could do something like this. So sometimes it's easy to split that apart. Just make sure you're actually adding those numbers together at the end. That's just something. It's just a cool little trick with multiplication. Cool is a loose term. I know you probably don't think it's cool, but it's something that you could use in real life. Okay, a little multiplication trick. This is more. This is kind of like a double distribute. All right, but what it really is, and you've heard this word before, and we're going to talk about it in a minute. It's a FOIL. It's FOIL, guys. It's FOIL. We've done FOIL in the past. This is just showing a double distribution, meaning I'm going to multiply x to everything, and then I'm going to multiply 2 to everything as well. All right. FOIL, we know FOIL. Okay, so then I just went down to this. All right, there's this box method. I don't know, depending on who you had when, for Algebra 1, or Algebra 2 for that matter, and how they taught this, okay, or if they taught you this. There does exist this box method out there that some people find helpful, all right, and, especially when it comes to factoring. And like if I have x and 2, and I'm just going to show you how it works out, even though it's written up here. All right, I'm going to show you how it works. This box is followed by multiplying x times x. This box is obviously followed by multiplying 3 and x. This one is x and 2. And now that I'm doing this, I don't know why I'm writing this out again. It's 3 and 2. All right, so all we do on this, guys, it's the same idea, same general idea, except we're using the box, all right, to kind of organize our thoughts, because now I know, oh, look, I have 2 like terms, and I need to combine those 2 like things as well. Okay, just a different way of thinking about it. It can be helpful when we're multiplying something like this. What I want you to do, we're going to do part B together as a class, and then we'll do number 5 together as well, because they can be kind of confusing. I want you to try part A. Try part A. Go ahead. Multiply these 2 things. You can FOIL it out. You can use the box method, whatever you want to do. I'll show both. Pause it up. All right, so there's both methods for you, okay? Just going regular FOIL here and then using the box method down here. So now I'd like to head back to class. We're going to do part B as a class, all right? And then we're going to talk about working backwards in number 5. See you later.